Okay, think for a second about the actual fate of our world. It doesn't rest in our bustling cities or tech hubs, but rather on two seemingly unrelated, deeply wild patches of nature. Welcome to today's Explainer, everyone. We are going to take a really rigorous comparative look at two of the most critical, yet incredibly vulnerable ecosystems on the planet. We're setting up a detailed case study of the Congo Basin in Central Africa and the Sundarbans Mangrove Forest over in the Bay of Bengal. By the end of this lesson, you're going to understand exactly how natural dynamics and some pretty intense human interventions are pushing these ancient habitats right to the edge of a critical threshold. All right, let's dive into this. Here is our syllabus for today. We'll start off with global sinks and ecological baselines, then move into Congo Basin terrestrial threats, followed by the Sundarbans coastal squeeze. From there, we'll look at shifting flora and fauna, the global carbon cycle, and wrap everything up with conservation and management. Section 1. Global sinks and ecological baselines. Before we get too deep, let's make sure we're grounded in the core academic terminology we'll be using. First up is carbon sink. You can kind of think of this as a massive planetary sponge. It's a natural environment that soaks up the heavy carbon emissions of the Industrial Revolution, essentially absorbing and storing way more carbon dioxide from the atmosphere than it releases. The Congo Basin acts as one of the most significant of these sinks on Earth. Second is the intertidal zone. This is the area where the ocean meets the land between high and low tides. And, this isn't just a static beach. It's a relentless daily tug of war between land and sea, and that's exactly where the Sundarbans ecosystem thrives. And this brilliantly illustrates the absolute contrast between our two case studies. On one hand, you have the Congo Basin. It's a massive terrestrial rainforest covering a truly staggering 300 million hectares. Its ecosystem is primarily driven by deep convection rainfall. It's actually one of 3 global hotspots for huge tropical thunderstorms. But then, on the other hand, look at the Sundarbans. It's a mere fraction of that size, incredibly concentrated at just over 10,000 square kilometers, yet it stands as the world's largest coastal mangrove delta. Its primary driver isn't just the rain, but the constant churning confluence of tidal saltwater and freshwater rivers. Section 2. Congo Basin terrestrial threats. 54,000 miles. Think about that distance for a second. To put that into perspective, that is more than twice the circumference of the Earth. And that is just the length of logging roads built inside the Congo Basin over a mere 15-year period between 2003 and 2018. This infrastructure doesn't just remove trees, it actively fragments the deep rainforest. It takes this continuous, resilient ecosystem and slices it up into smaller, vulnerable blocks. That allows for even further human encroachment and aggressively alters the local moisture cycle. So the crucial point here is that this internal fragmentation and industrial logging are acting as powerful catalysts. The logging industry now covers anywhere from 44 to 66 million hectares of the forest. And the data is pretty shocking. We saw the deforestation rate in the Democratic Republic of the Congo literally double from 2015 to 2019, and then it jumped an additional 5% in 2021. This isn't just a matter of losing a few trees, right? It's about pushing the entire basin toward a dangerous climatic tipping point. If the forest cover drops too low, that deep convection rainfall system we talked about could be permanently altered, essentially drying out the remaining forest for good. Moving to Section 3, the Sundarbans coastal squeeze. Now, halfway across the world, the Sundarbans is facing what ecologists call a coastal squeeze. It's basically trapped between immense natural cyclonic pressures and devastating human interventions. On the natural side of things, you have catastrophic storms like Cyclone Sidra, which damaged a full 40% of the forest back in 2007, along with a natural neotectonic tilting of the basin. But on the flip side, human activities are accelerating the collapse. You have industrial pressures like the proposed Rampal coal plant, the upstream diversion of fresh water at the Faraka Barrage, and massive ecological shocks like the 2014 Southern Star 7 spill. That event dumped 358,000 liters of furnace oil into protected rivers, 358,000 liters of toxic oil in a single event. Just imagine the immediate lingering suffocation of that incredibly delicate mangrove root system. Let's walk through how this creates a lethal chain reaction for the mangroves, step by step. First, climate change is driving sea levels up by about 8 millimeters annually in this region, and that's accompanied by a 1.5 degrees Celsius rise in surface water temperatures. Second, the vital freshwater that usually pushes back against the ocean is being increasingly diverted upstream for human agriculture. And step 3 is the inevitable result: aggressive saltwater intrusion. The salinity of the soil and water across the delta increases exponentially, effectively poisoning the native plants because they simply cannot adapt fast enough to the changing chemistry.
Section 4. Shifting flora and fauna.
Now, what's really interesting, and frankly quite alarming, is how this specifically impacts the native trees that actually give the Sundarbans its identity. The forest is literally named after the Sundari tree, but because of this heightened salinity we just tracked, forest inventories are showing a staggering 40% decline in the standing volume of the Sundari tree and a 45% decline in the Gewa tree. The changing chemical makeup of the water is actively driving the localized extinction of these super-sensitive foundational mangroves. And as you might expect, when the flora collapses, the fauna rapidly follows. Over in the Sundarbans, the legendary Bengal tiger population is now heavily constrained. There are just roughly 180 individuals left, backed into a shrinking corner of the delta. Rare Irrawaddy and Ganges dolphins are literally fighting to survive toxic oil spills in the waterways. Meanwhile, back in the Congo, the United Nations Environment Program has warned that the majestic western lowland gorillas face the very real threat of extinction from the greater basin within just 15 years. Across both of these regions, apex predators and megafauna are losing their critical habitat to environmental degradation and agricultural expansion. So we have to ask ourselves, why does the localized loss of a specific mangrove tree or an equatorial gorilla matter to the rest of the world?
Which brings us to Section 5, Global Carbon Cycle.
30 billion tons. Back in 2017, scientists discovered that the peatlands in the cuvette central of the Congo Basin contain this completely unfathomable amount of carbon. To put that heavy number into perspective for you, that represents 20 years of total United States fossil fuel emissions, and it is locked entirely within the dense soil and root systems of this one localized area. If these vital carbon sinks revert and suddenly become carbon sources, we are looking at an irreversible planetary emergency. Current predictions for unabated deforestation are terrifyingly clear. Quote, by 2050, activities in the Democratic Republic of the Congo will release roughly the same amount of carbon dioxide as the United Kingdom has emitted over the last 60 years, end quote. If we push these ecosystems past their tipping point, the carbon released will drastically accelerate global climate change, basically creating a runaway feedback loop that affects every single living thing on Earth. Finally, Section 6, Conservation and Management. With the stakes literally this high, our conservation strategies absolutely have to adapt to the unique geography of each region. In the terrestrial Congo Basin, the approach has been largely economic and regulatory. A 2002 World Bank moratorium actually provided $90 million in aid in exchange for halting new logging concessions, and new forestry codes now require a sustainable 25-year cycle of rotational logging. Conversely, the Sundarbans requires a massive coastal adaptation approach. Even with robust international protections like UNESCO and Ramsar, the encroaching ocean is a physical, relentless barrier. Experts are now recommending managed retreat for human populations alongside intense mangrove restoration. And understanding managed retreat is absolutely crucial here. It means recognizing that to survive climate change, we sometimes have to yield to nature rather than just endlessly trying to fight it. Which leaves us with the ultimate question. Will our adaptive conservation methods actually outpace the global climate tipping point? Can rotational logging and managed retreat save the deep convection rainfall of the Congo and the delicate salinity balance of the Sundarbans? These are not just academic questions for a test, guys. They are the defining ecological challenges of our time. I highly encourage you all to look deeper into the research coming out of these regions. Are we really prepared to accept a world where these vital lungs and coastal shields no longer exist? Thank you so much for joining me for this explainer. Keep asking the hard questions, and I'll catch you next time.